in this question it is given that the minimum value of the function fx equal to this is, you have to find the correct choice. Before I do this question, I would like that you should remember these formulas. The formulas which I am going to tell you, they are very useful formulas in the questions of definite integral. You can do the questions without using these formulas also, but using these formulas make our solution short. The formula says that if a to b fx dx is written, many times I have to bring x plus c instead of x. If I have to bring x plus c instead of x, then I will have to subtract c from lower limit and upper limit. Or you can say in this way also, sometimes we have to subtract a constant from lower limit and upper limit. If I have to subtract the constant, I will have to add c in the value of x. Similarly, obviously, if I write x minus c dx, I will have to write a plus c and b plus c. Obviously, this clear. And sometimes we have to bring x by c instead of x. If I have to bring x by c, then I will have to multiply by c in lower limit and upper limit. And if I have to write x by c, then you will have to write 1 by c outside also. And obviously, if I have to bring f c into x, then outside will multiply by c, and here you will be dividing by c. And a particular case of it, that is sometimes we have to bring minus x for x, that is c is minus 1. Obviously it will become minus a minus b f minus x dx. That is, if you are required to bring minus x for x, then you will be writing minus a minus b and minus outside. All these formulas are very useful formulas, and I'll be using these formulas because using these formulas make our solution simple and short both. Obviously, if instead of x minus c only t is there, then it will be easier to deal with. Hence, to remove x, note that for this integral x is a constant, variable is t, and because for this integral x is constant, I can use these formulas. First I write to remove x for t, I will be writing t plus x, then this x will get cancelled, and because I'm going to write t plus x for t, I will have to subtract x from lower limit and upper limit, and I will be getting minus x 2 minus x e to the power mod of x minus t plus x dt. That is, I will get minus x to 2 minus x e to the power mod of minus t dt. Obviously this is minus x 2 minus x e to the power mod t dt. Obviously it will be slightly more simple had it be plus x here and here. It's not necessary, but had it be plus x here and here, it will become slightly more simple. Therefore, as I told you, if I want to write minus x for x, I will have to take negative here also, and here also. And here the variable is t. This will become equal to minus x, and negative of this will be x minus 2 e to the power mod of minus t dt. This is equal to mod of minus t, same as mod t, but it is always more friendly if the smaller limit is here and bigger limit is here. Therefore, I remove minus sign. I write x minus 2 to x e to power mod t dt. Now you can see very easily it will be slightly more simple to deal with as compared to this. It's clear that if both are positive, that is x minus 2 and x both are positive, and because t is varying between x minus 2 and x, and if both are positive, mod t will become t. And if both are negative and t is lying between x minus 2 and x, therefore t will become negative. Therefore, after removing mod, minus t will come. If this is negative and this is positive, in that case, what I will do, you can see. First, I am dealing with the case if both are negative, that is x minus 2 is negative and x is negative. Obviously, if x is negative, this will be automatically satisfied. That is, if x is less than 0, then because the value of t is varying between both negative numbers, therefore mod t will become minus t. And because fx is this, that is, this is fx, hence I will say fx is equal to x minus 2 to x e to power minus t dt. This is equal to e to power minus t upon minus 1 and x minus 2 to x, that is, I'll be getting minus e to power minus x minus e to power minus of x minus 2. That is, this is equal to e to power minus x plus 2 minus e to power minus x. Hence, we reach at the conclusion that fx is equal to e to power minus x plus 2 minus e to power minus x if x is less than 0. And take the second case, if x minus 2 is negative and x is positive. That is, if x is less than 2 and x is greater than 0. That is, it means x lies between 0 and 2. Some of you may be thinking that why I am not taking the case of equal to 0 or equal to 0 here. Actually, if I take equal to 0, then also it is correct. If I take just less than 0, then also it is correct. To understand this thing, I will say in this way that a to b fx dx is the integral. We know that this represents the area under the curve from a to b. Or if I say limit t tends to be a to t fx dx, both are sure to be equal because the only extra thing in it is t equal to b. That is area of this line, and the area of line is always 0. Therefore, a to t fx dx and a to b fx dx both are same if t tends to b. Hence, even if I take equal to 0, then also it is correct. If I don't take equal to 0, then also it is correct. It makes no problem. That is, whether I write equal to 0 here or both the cases or not at both the cases, it makes no difference. Note that this is correct in the case if the integrand is a continuous function. If integrand means this thing. If integrand is discontinuous in this interval, then limit and value may not be equal. And if x lies between 0 and 2, which means x minus 2 is negative and x is positive, that is 0 lies between x minus 2 and x, then it will become equal to x minus 2 to 0 e power mod t dt plus 0 to x e power mod t dt. And in this case, because t is lying between x minus 2 and 0, that is t is negative, hence we will be getting e power minus t dt and x minus 2 to 0 plus here t lies between 0 and x is positive, hence you will be getting 0 to x e power t dt. That is, in this case you will be getting e power minus t upon minus 1 and x minus 2 to 0 plus e power t 0 to x, and this is equal to e power minus of x minus 2 minus 1 plus e power x minus 1. That is, we get e power x plus e power minus of x minus 2 minus 2. Hence we reach at the conclusion that fx is equal to this thing if 0 is less than x less than 2. And last, if both x minus 2 and x are positive, x minus 2 is greater than 0 and x is greater than 0, which clearly means x is greater than 2, because if x is greater than 2, this is automatically satisfied. And in this case I get fx equal to x minus 2 to x e power mod t dt, and because both are positive, x minus 2 to x e power t dt, that is e power x minus e power x minus 2. Hence finally we have got the conclusion that fx is equal to this thing if x is less than 0, that is e power minus x plus 2 minus e to the power minus x if x is less than 0, and if x lies between 0 and 2, from here I can say e power x plus e power minus of x minus 2 and minus 2. And third case, if x is greater than 2, from here I can write e power x minus e power x minus 2. And it is very easy to see that for x equal to 0 both are giving same answer, for x equal to 2 both are giving same answer. And I told this thing geometrically also that for equal to 0 and equal to 2 the answer is going to be same. And according to this I have to find the minimum value of fx. Hence I get f dash x equal to minus of e power minus x plus 2 plus e power minus x if x is less than 0, and if x lies between 0 and 2, then I will be getting the derivative as e to power x minus e to power minus x minus 2, and if x is greater than 2, derivative will be e to power x minus e to power x minus 2. And if we put this equal to 0, we will not be able to find the value of x. See, minus of e to power minus x plus 2 plus e to power minus x equal to 0 means e to power minus x is equal to e to power minus x plus 2, that is 1 equal to e square, which is not possible. Similarly, if I put this equal 0, e to power x is equal to e to power x minus 2. This means 1 is equal to e to power minus 2. Again, not possible. But if I put this equal 0, I'll be getting e to power x equal to e to power minus x plus 2. That is e to power 2x is equal to e to power 2. That is 2x equal to 2. That is x equal to 1. Hence, x equal to 1 is the only point where f dash x is 0. Hence, maxima or minima will occur only at x equal to 1. And now let us check for x equal to 1. It is maxima or minima. Clearly, this is equal to e to power x minus e to power 2 minus x. If I take the value of x as slightly less than 1, this will be slightly more than 1. Hence, the value of this will be negative. And similarly, if I take the value of x slightly greater than 1, then the value of this will be more than this. Therefore, the e to power x minus e to power 2 minus x will be positive. That is, before one graph is decreasing, after one the graph is increasing. Hence, at x equal to 1, fx will have local minima. Hence, at x equal to 1, the value of fx will be minimum. And the minimum value will be f1 equal to 0 to 2 e to power mod of 1 minus t dt. Either I can do it in this way. First case when 1 minus t is negative, second case when 1 minus t is positive, but that is a bit lengthy. But this thing will make it short, which I told you in the very beginning, that for t right, t plus 1. The benefit will be 1 will get cancelled. And if I am writing t plus 1 for t, here I will have to subtract minus 1 to 1 e to power mod of minus t means mod of t dt. And because it is even function, it is 2 times 0 to 1 e to power t dt. That is 2 times e minus 1. Hence, I can say first choice is the correct choice.